All right, what is this? All right. Let us suppose that we have an angle in standard position. Let us suppose, this is a key notion. So given theta in standard position, and we are given theta is not quadrantal. So if theta is quadrantal, I am not talking about that. If theta is 180 degrees, I'm not talking about that. If theta is 270 degrees, I'm not talking about that. If theta is 90 degrees, I'm not talking about that. Given an angle in standard position that is not quadrantal. Let me ask you something. What is the sine of pi? What is the sine of the number, 3.141596 pi? What is the sine of pi? Well, the problem with that is there are two correct answers. Because there are two ways to interpret what I just said. One way to interpret that is this. What is the sine of pi? We will find out later on. We will find out. This is much later on. You do not need to know this for now. But later on, we will find out that the sine of pi here is equal to 0. But you know this already from your glory days in basic algebra. One way to interpret, if I ask you what is the sine of pi, what is the sine of pi? Well, the sine of pi is positive. And that's the issue. SIN is sine, SIGN is also sine. So the question is, which one do we mean? Here's how we get around that. In trigonometry, sine means this. If this is what you mean, we don't say sine. We say the Latin form of the word signum. And now there's no confusion. What is the sine of pi? The sine of pi is 0. What is the signum of pi? The signum of pi is positive. If we mean this, we can say signum and there's no confusion. So if I ask you what is the signum of -4, the signum of -4 is negative. All right? If I ask you what is the sine of 0, that has to do with the trigonometry. It turns out, you don't know this yet, turns out the sine of 0 is 0. But what is the signum of 1? That's what's the signum of 1. Signum of 1 is positive. All right? So, what I want to ask is this. Given our angle in standard position, suppose theta is somewhere in quadrant 1. Theta is here. There's theta. Theta is a quadrant 1 angle. Consider the sine function, sine of theta. Consider sine function. We know sine is y over r, right? In quadrant 1, watch what happens. This is the y value. This is the r value. If theta, now here, think this problem. If theta is in quadrant 1, r is always positive. It doesn't matter what quadrant we're in. R is always positive because from the very definition, r was greater than 0. From way back when we first started x, y, r definitions, the requirement was r cannot be negative. So r is always positive. If you're in quadrant 1, the y value is positive. So consider the sine function. Consider, this is theta. Consider sine of theta. All right? If you're in quadrant 1, sine of theta is a positive number. It's y divided by r. All right? But what if you're in quadrant 2? What if this is the picture? Right? What if this is theta? What if you're a quadrant 2 angle? Where is R? Well, R is here. R is always positive, right? Is that right? Positive. Here, y over R is positive over positive, which is positive, right? But in quadrant 2, y is positive. We have positive over positive. And so in quadrant 2, positive y divided by positive r is a positive number. What if theta is in quadrant 3? Now look, the y coordinate is negative. Right? The y coordinate is negative. But what about r? R is positive no matter what. Negative divided by positive. For sine of theta, in quadrant 3, it's a negative number. Let's do an example. 180 degrees, 270 degrees, 200 degrees. If you took a calculator and took the sine of 200 degrees, your answer would be negative. Because any angle in quadrant 3, sine is going to be a negative number. And then finally, if you're in quadrant 4, there's the y coordinate. This is negative, is that right? Y is negative, but r is positive no matter what. And so we have negative divided by positive. What's negative divided by positive? That's negative, right? So that's the moral of the story. If we're talking about the sine function, in quadrant 1 is positive, in quadrant 2 it's negative, in quadrant 3 it's negative, positive, in quadrant 4 it's negative. We have that. Say that again. Positive, I said it backwards here. Positive, positive, negative, negative. That's the sine function. Is it clear we could go through that same long, arduous, I didn't make it very well argument, not just for sine, we could make it for cosine. We could make it for tangent. If you did that, this would be the result. This is the memory device that every trig student remembers. This is the memory device that every trigonometry student remembers. I've never met a trigonometry student in a calculus class. If you've taken trigonometry, you know this. This is like the back of your hand. All right, here's how it works. This tells you the quadrants in which the functions are positive. This tells you where they're positive. If you want the negative, do the opposite. This tells you where the functions are positive. In quadrant 1, this stands for all. In quadrant 1, all functions are positive. That's it. In quadrant 1, all functions are positive. In quadrant 2, sine is positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. The memory device that every student learns, you might as well join the club. Oops. ASTC, the memory device is all students take calculus. All students take calculus. All students take calculus. That's how you remember it. Now, what does it stand for? All functions are positive in quadrant 1. Sine is positive in quadrant 2. Therefore, sine is positive in both. Sine is positive in quadrants 1 and 2. All, and then sine is positive in 2. All right? All students take calculus. What about tangent? Tangent is positive in quadrant 1. It's also positive in quadrant 3. So tangent is positive in quadrants 1 and 3. What about cosine? All functions are positive here. Cosine is positive in quadrant 4. Therefore, cosine is positive in quadrants 1 and 4. Each function is positive in 2 quadrants and negative in the other. So if you know sine is positive in 1 and 2, then for free you get to know that sine is negative in 3 and 4. if you know tangent is positive in 1 and 3, then you know tangent is negative in 2 and 4. And similarly, cosine, positive in 1 and 4, negative in 2 and 3. This is what sometimes students wonder about this. Remember, let's consider tangent just very, very quickly here. First off, it should be clear everybody's positive in quadrant 1 because everything's positive in quadrant 1. But in quadrant 2, let's suppose this point is negative 3 comma negative 4. Right? So this is negative 3, this is negative 4. But what is tangent? Tangent doesn't have anything to do with r. Tangent has to do with y divided by x. Negative divided by negative ends up being positive, and that's why tangent is positive in quadrants 1 and 3. All right? So we can ask questions like this. What two quadrants is cosine negative? What two quadrants is cosine negative? Cosine is negative. Well, it's positive here and here, therefore it's negative here and here. So cosine is negative in quadrants 2 and 3. That just becomes part of your baseline knowledge. I've never encountered a trigonometry student who had trouble with this. I've never encountered it in a calculus sequence. All students know this. You're going to get this like everybody else does. It's very straightforward. Now, a reasonable question is, okay, what about secant? Well, remember, secant is just the reciprocal of cosine. And when you form the reciprocal, you don't change the positive negative, you just have the reciprocal. So if this is negative, when you form the reciprocal, it's still negative. If this is positive, when you form the reciprocal, it's still positive. And so, if you know this, all students take calculus, all, sine, tangent, cosine. If you know this, then you also get cosecant and secant and cotangent for free. Because cotangent is always the same as tangent. Remember the reciprocal relationship from earlier? Secant is always the same as cosine, as far as this is concerned. And cotangent is the same as tangent, and cosecant is the same as sine, as far as this is concerned. If all you're interested in is the quadrants where it's positive and negative, this gets you everything you need. This gets you everything you need to know. It's right here, ASTC, all right? And remember, it's all students take calculus. What does that mean? This means this is where they're positive. All functions positive. Sine, and therefore cosecant, is positive in quadrant 2. Tangent, and therefore cotangent, is positive in quadrant 3. Cosine, and therefore secant, is positive in quadrant 4. Secant is positive at the same place cosine is. Whereas cotangent, negative. Cotangent agrees with tangent. Tangent's positive here, therefore it's negative here. Cotangent is negative in quadrants 2 and 4. Remember, cotangent is negative is the same thing as saying less than 0. Less than 0 means negative. So if you're given cotangent theta is less than 0, that's cotangent's negative. That means you know you're in quadrant, you tell me, where's cotangent negative? Yeah, quadrant 2, quadrant 4. Remember, I always do my Roman numeral 4s like this, because if you write too many Roman numeral 3s like 4s like this, it starts to look like a 3. So I will always draw my Roman numeral 4s this way. So now we can do all sorts of things. And by the way, on exam day, if you can't smell multiple choice questions coming here, you're not sniffing very hard. This is the easiest multiple choice question in the world to write. You can write a dozen multiple choice questions on this stuff in the time it takes to, I don't know, do something that doesn't take very long. Because if sine is greater than 0, what is the quadrant? What quadrants? Right? Well, positive, greater than 0 means positive, so that's quadrant 1. Where is sine positive? In quadrant 1 and quadrant 2. Later in the semester, we're going to solve equations. If you don't know this, you cannot solve the equation. The end. You must know this. There's nothing for it. You need to know where, in what quadrants, each of the functions are positive or negative. If you don't know that, then exam number 4 is just not going to happen for you. So you must know this. It is absolute bedrock. So learn in what quadrants which of the functions are positive and which ones are negative.